Welcome back. Today we're going to be talking about literal equations. Now what that means is we're going to be looking at a bunch of equations with very few numbers in them, all letters. And we're going to be solving for these. But the thing to remember is when we're solving for these, we're really not solving anything, we're just moving things around. The best way I can explain it is think about your room, how it is right now. You have your bed in one area, your desk in another area, your dresser in another area, maybe a light, another nightstand. You have all these different elements in your room, and you just want to rearrange it. You know, instead of the bed being on that wall, you're going to put it on this wall. You're going to take the dresser over here and move it over there. You're going to take the TV and move it from this stand over to this stand. Nothing's changing in the room. We're just rearranging it so it fits a little bit better or for how you want to make it work for you. That's what, when we're talking about literal equations, that's what we're going to be doing. We're still going to be using all those different rules we did before. Whether we're adding opposites, whether we're multiplying by something or dividing by something, all those things we were using before. So to start with, the best way to do this is just to look at different problems. So the first problem is G equals CA plus B. I want us to solve for B, which means I want to get B all by itself. So it's B equals something. That's our goal. So when you have these problems, it's a great idea maybe to highlight that variable. Like with this, I kind of made my B in red. The rest of it's in black. So I want to ask myself, again, I'm still going to draw that line down the middle. And I want to get B by itself. So what are these two variables doing to the B value? First of all, we have to understand that it's C times A plus B. Now, if this is one quantity, this is one term. How did we get something, if we had something being added to B? What did we do? Think back. Did we combine like terms? Did we add opposites? Did we multiply or divide? Did we distribute? Something's being added? We added opposites. What's the opposite of CA? Negative CA. We added opposites here. I'll put this in red so you can see it. We added opposites. Same thing we've been doing except we don't have numbers. Now, this ends up canceling out. We're left with B. We got B all by itself. Now, can we combine a G and a CA? Are those like terms? All we do is rewrite this. G minus C times A. And we are done. That's it. No solving, no numerical answer. We're just moving around where these variables are. G equals CA plus B is the same thing as B equals G minus CA. Same exact thing. Let's look at number 2. We have G equals B times C. I want to solve for C. So I look at the problem. What is B doing to the C? It is multiplying. How do we get rid of that B? When it's multiplying, what's the opposite of multiplying? Divide by B. So divide both sides by B. So we're going to divide. In this case, because it's the opposite of addition, of multiplication. So our final answer is just G over B equals C. We did that one step, and we solved for C. We got C all by itself. Number 3 is very similar. Take a look at 3 and compare it to number 2. We want to get X. We want to solve for X, meaning we want to get X by itself. What is the F doing to the X? It is multiplying, so it's the opposite of multiplying, divide. Just like we did in number 2. We're going to divide by F, and we're going to end up with X equals P divided by F. and we are done. There's 3 examples right there. Now we're going to do 3 more. As we're walking through these, think about what needs to be done to solve these. So if we're looking at number 4, we have m over x equals p minus n. I want to solve for p. What needs to be done here? Well, I know I want p by itself, and there's a minus n. What is the opposite of minus n? We want to add the opposite. So it's the opposite of negative n, positive n. So we're going to add n here and add n here. This cancels out. So again, I'm left with p on the right-hand side. On the left, I can't combine any of these. But what I can do, I can rewrite it. M divided by x plus n equals p. There's that answer. One step. There's only one thing being done with the p, one step to solve it. Now here's a formula you might find familiar. D equals m over v. Density equals mass over volume. If you haven't used it in science class yet, you will this year. Definitely see it this year. And you're going to have to manipulate this to make the formula work for you. Now I want to solve for m. So I have D equals our m, which we want to get by itself, divided by v. Now what's the opposite of division? Multiply. We want to multiply both sides by v. These v's cancel, and we're left with d times v equals m. We got m all by itself. And then the last one. These letters, x and y and m, we're going to start working with these in a not so distant future when we start talking about linear equations. This one we're going to solve for y. Think about it. How are we going to get y by itself? What is the y and x doing? They are dividing, so in order to get the opposite of division is multiply. So I want to multiply by x to both sides. The x's cancel here, and we are left with y equals m times x. And we have the y value by itself. So there are 6 problems we just went over. Now I guarantee there's a good chance when you're looking at all these problems, looking at all the variables and not looking at numbers and being like, this isn't math anymore. Right, it's algebra. And this is what we're kind of getting into more and more of. Think about doing the exact same thing. Don't let the letters throw you for any loops. Just think about it. Always do the opposite operation. Something's being added to the variable we want to solve. Add the opposite, which is a negative. Something's being subtracted. Add the opposite, which would be a positive. If it's being multiplied, the opposite of multiplication, divide by that. And if it's being divided, then you multiply. Just like we've been doing over the past month. See you next time.